Today we're going to look at if a rocket is accelerated 80 meters per second squared for 15 seconds, how high will it go? We're going to end up using our kinematic equations. So let's think about this. This would be our max height. So this is the maximum height that will travel. Somewhere in here, the acceleration of this 15 or 80 meters per second squared is going to stop, and you're going to have a final velocity up here. So in other words, the rocket is going to be accelerating between here and here. Right, and then the rocket engine is going to stop, and then the rocket will just keep on going, but it will end up slowing down. So in this section, our acceleration is going to be 80 meters per second squared. We know our time is equal to 15 seconds. So two things you want to look for. You want to look for the final velocity, and you want to look for y over here. So I want to know how high this rocket is going to go with this particular acceleration. So if my acceleration is 80 meters per second squared, it accelerates for 15 seconds. How high is this going to go? I need to find that. Then we're also going to find out how high it goes from here to here. So we're going to end up adding these two y's together. So let's see how this goes. First thing I would do is probably just find the final velocity here. Number one, or I'm sorry, let's find y first. Let's go with y. So y in our kinematic equation is going to be equal to velocity initial times time plus 1/2 at squared. Okay, well, let's look at our velocity initial down here. The rocket is at rest down here, so the velocity initial down here is going to be equal to 0 meters per second. When the rocket starts, it's at 0. So as it accelerates upward, it's going to have a final velocity. So we know this thing right here is 0. We don't have to mess with it. So we end up in y is going to be equal to 1/2 my acceleration, which is going to be 80 meters per second squared, and then my time is going to be 15 seconds squared. So at 15 seconds, and we're going to end up squaring that. Y ends up being, I came up with close to 9,000 meters. So we know now that with this acceleration, this rocket, we're not worried about F equals ma right now. We're just going to use kinematic equations. We're not worried about the dynamics. We're just worrying about that it has an acceleration, how much time it was accelerated. With this acceleration of this rocket, it's going to go about 9,000 meters. Let's find out how fast it is before the engine turns off here. We're going to use velocity final squared is going to be equal to velocity initial squared plus 2 times a times d. All right, so I know my velocity initial is 0 in this case, because we know that it started out at 0, so we know we can just get rid of that right away. This is just 0. So my velocity final is what I'm looking for. So I'm going to take the square root of both sides. I'm going to end up taking the square root of this side and that side. So I know that my velocity final is going to be equal to 2 times my a, which is 80 meters per second squared, times my distance. Now that I know this is 9,000 meters, I can plug that in here now. This will be 9,000 meters, and we're going to take the square root of that thing. My velocity final will be equal to that. And once you take the square root of that thing, you get about 1,200 meters per second. So I know now that when this rocket is done with its acceleration, I know that that velocity at that very second is going to be equal to about 1,200 meters per second. Okay, I'll let you take a picture of that if you like. All right, let's go into the next step. So we kind of found out what's going on in this area. Let's find out what's going on in this area. So to go into this area, I think the first thing we should try to do is probably try to find the distance that this thing travels. That way we can just add it to the 9,000 meters, and then we'll know our total max, and that's part of our question. So how are we going to find that? We're going to use velocity final squared is going to be equal to velocity initial squared plus 2 times a times d. Well, I think this d is what we're looking for. So we're going to end up solving for this d. I know my velocity final up here, as the rocket comes to a stop, it will come to a stop up here, so I know my velocity final is 0. So I need to bring my velocity initial over here, which is going to be a negative, and my velocity initial is 1,200 meters per second. So I know this is negative 1,200 meters per second. And that's going to be equal to 2 times my acceleration, which is going to be negative 9.8 meters per second squared. And here's my d that I'm trying to find. That's this thing here, my y. All right, so don't forget, this is negative. This is the acceleration, and this side is, this is the acceleration. So g is going to be equal to negative 9.8 meters per second squared. That's the most important part, is to keep these two accelerations, they're not the same thing. And also, when you think about it, this particular acceleration has this g incorporated into it. Whatever this rocket is doing, the 80 meters per second squared, the 9.8 meters per second squared that's pulling down on this is incorporated in this acceleration. So we don't need to worry about that. All right, let's solve for d. So you're simply going to divide both sides by 2 times 9.8. So, and then the two negatives will cancel. I should probably just do it. Negative 2 times 9.8 meters per second squared is going to be equal to d. The negatives cancel. 2 divided by that, it becomes up to be 80. Now, don't forget, this is squared. This is going to come up with about 73. D is 73,470 meters. It's pretty high. It got up there pretty good. All right, so let's add up our d's. I know the d in the first equation was 9,000. My d in this part is 73,470. So I know my max height is going to be equal to about 82,470. That's going to be the maximum height. That's about 51 miles, 51.24 miles. So that's pretty high in the air for this particular rocket. Just for fun, I'd like to take a picture of that if you like. Let's find out what the average speed is between here and here. The average speed of the rocket. The average speed is just going to be really simple. It's just going to be my velocity average is going to be equal to the distance it traveled divided by the time. Well, my velocity average is going to be the distance it traveled, which was 82,470 meters divided by the total time. I didn't find the total time. Let's try the total time. Where would we do that? Well, let's see how we do that. Velocity final is going to be equal to velocity initial plus AT. Let's look at the first part. How long it took to go from, the first part, how long it took to go from there to there. Well, I know my A. I know my velocity final, so this would be 1,200 meters per second. It's going to be divided by my A, which is this right here, 80 meters per second squared, which is going to end up giving us a T. I came up with, let's see if I get this right. T comes out to be about 122 seconds. I'm sorry. This is 15 seconds. Duh. This is 15 seconds. I know this time. Let's go with this time up here. I don't know this time. That's right. Okay, velocity final is equal to, don't you love physics? Is it going to be equal to velocity initial plus AT? All right, let's find this time up here. So my velocity final is going to be 0, right? My velocity initial is going to be this thing here, which is negative 1,200 meters per second. And then my A over here is going to be the negative 9.8 meters per second squared, which is going to be equal to my T. Because we're talking about for time from here to here, so the only acceleration going on right now is gravity. So the negatives cancel, fortunately, because we went negative time. This time I came out to be 122.45. There we go, 122.45 seconds. All right, so we're almost home. We almost can put our time in here. We need to just add 15 to this, and when you add 15 to this, because this traveled for 15 seconds, this traveled for 122.4, you get 137 point, this is actually 4.5 seconds. So you get about 137 point, I came up with 37, I just rounded up 5 seconds. So about 137.5. This is our total time. That's important to realize that what we were finding. We already knew this one here. So we're going to find how long it took to go from there to there. We use this equation to get that. Then we added this 15 seconds right down here to this to get the total time, which if we put up here, 137.5 seconds. Let's see what the velocity average is. I think you'll be surprised. Okay, 82.470 divided by 135.7 velocity average comes out to be about 600 meters per second. It's actually 599.8 something. But so there you go. This is how you would do a problem when they say how far a rocket, if it's accelerating 80 meters per second for 15 seconds, how high will it go? Split it up into two sections. All right, don't try to do the whole thing at once because it will get too confusing. You can do the whole thing at once. You can actually subtract these two, but I think it's just easier if you just break it down, just do one section at a time, make sure that you add those two sections together. I hope this helps you, and I hope you subscribe to Physics Station 124.